Hello everyone, in this video I'm going to be answering the questions for chapter 2 review. So let's go to question number 1. It says the GMG Casino has a new game. In order to play the game, you had to pay $2. There is a 45% chance of losing $4, a 25% chance of breaking even, 20% probability of winning $3, and a 10% probability of winning $10. The first thing we have to figure out are the possible values for x. So how do we get minus 6, 0, 1, and 8? There is a 45% chance you're going to lose $4. Since you had to pay $2 to play, that means you actually lose $6. There's a 25% chance of breaking even, which means you made $2, but since you had to pay $2 to play, that's how you get 0. And so on. Like, there's a 10% chance of winning $10, you actually only win A, because you had to pay $2 to play. Now the probabilities, according to the information, is 0.45, 0.25, 0.20, 0.10. The first thing you need to check is that this actually add to 1. Otherwise, you do not have a random variable. The first part of the question is asking you to find the expected value, or mu. Remember, the formula, which is given on the formula sheet, is this. It's the sum of x times p of x, which means you multiply these two and add it up. Whatever you hear, that's the mean. If we multiply these values, we get minus 2.70, 0, 0.20, and 0.80. If you add it up, you get negative 1.7. Hence, the mean is this one, which is negative 1.7. Part B is asking you to find the variance. Remember, the formula for the variance is equals to the expected value of x squared minus mu squared. We already have this one. All we need to figure out what this is. That will come from whatever value you get here. How do we get this value? You have to add all of these values. How do we get any of these values? You square x, multiply times p of x. For example, here, this one you have to square negative 6 and multiply times 0.45, which will give us 16.2, 0.2, then a squared is 64 times 0.1, 6.4. If you add everything, we end up with 22.8. You can stop the video at any time here and check yourself that those are the values that you should get. Hence, this value, remember, represents the expected value of x squared, which is the value that will go here. So therefore, from here you have sigma squared, 22.8 minus 2.8, minus 1.7 squared. If you square that, that's when you get 2.89, and this simplifies to 19.91. If you wanted to find the variance, you take the square root, the standard deviation, you take the square root of this, but the question is just asking for the variance. So once you get to this point, you are done. Finally, for this problem, part C is asking what's the meaning of mu, or what is the expected value. What this means is that every time that you play this game, you should expect to lose, $1.70, which is a pretty bad deal. Let's move to question number 2. Question 2 is a binomial question, even though it doesn't say that, because if you are an Angelino, you either own a drone or you don't. You only had two choices. Here, the success probability is 20%, and the sample is 25. I have the formula on the right side, on green, and part A is asking you what's the probability that exactly 2 of n on a drone. So the question is, how much is this? If we plug it into the formula, this is 12. Sorry, again. This is 25, choose 12, times 0.2 to the 12 power, times 0.8 to the 13 power. Remember that this plus that has to add to 1, and this plus that has to add to n. And you can leave the answer like this. There's no need to go any farther on the test. Okay, in part B, the question is, what's the probability at least one will own a drone? So mathematically means this. Remember, the complement of this is this. We talked about that many times. So you use the same formula, this one, with x equals to 0. You will get 25, choose 0, times 0.2 to the 0 power, times 0.8 to the 25th power. And again, you can leave the answer like this, and you are good to go. Finally, for this question, it's asking you to find the expected value of x, which, remember, is the same thing as what is mu, and for the binomial, this is equals to n times p. N is 25, p is 0.2, this is equals to 5. So you expect 5 people to own a drone, and that's it. Question number 3, a poll is conducted to find the true proportion of people in California that own a dog. Here we have that n is 500, x is 200. So from here we know that p hat is 200 over 500, which happens to be 0.4. Since we want a 99% confidence interval, that means that alpha is 0.01. Remember, whatever you need to make 100%. So step 1, alpha divided by 2 is equals to 0.005. From here we need 0.005, which is 2.58. Then step 2, the margin of error is equals to 2.58 times the square root 0.4 times 0.6 divided by 500. This is equals to 0.056, and if you round it to 2 decimal places, which you don't have to, get 0.06. Then remember step 3, you have to do p hat plus or minus e, which in our case will be 0.4 plus or minus 0.06. Then the answer will be p is between 0.46 and 0.34. Remember that you had to explain what this means. And what this means is that we are 99% confident or sure that between 34% and 46% of Californians own a dog. And that's it. Part B is asking what's the margin of error. The margin of error is just a step 2. So in this case, the margin of error is 0.06 or 6%. Part B is asking how large of a sample is needed in order to have a margin of error of 3%. So this is telling us that E is 0.03. If we plug it into the formula, this is the formula, which is given on the formula sheet 2. If you plug in the values, we have that N is equals to 2.58 over 0.03, which is the margin of error, squared times P, which is 0.4, P hat, remember, is 0.6, and if you round it to a whole number, this turns out to be 1775. Okay, let's move to question number 4. This is a normal distribution. Here the mean is 66 and the standard deviation is 4. So this says the height of male students is normally distributed. Part A is asking you what's the probability that a randomly chosen student will be taller than 75 inches. So it's asking what's the probability that X is greater than 75. So the first thing we have to do is change everything to standard normal. And to do that, Z will be 75 minus 66 over 4, which happens to be 2.25. So therefore, this is equivalent to finding the probability that Z is greater than 2.25. You need to shade the area that you want. So this is what we want. And then you can use either the table or the calculator. You look to the table, the area to the left, according to the table, is 0.9878. So you use the table, it will be 1 minus 0.9878, which is 0.0122. You use the calculator. This is the same thing as normal. CDF, the lower bound is this, the upper bound is infinity, which we're using 1,000. So this is 2.25, 1,000, and it will give you exactly the same value. In part B, we have the same information, but the question is now asking what's the probability that X, which is the height, is less than 62. If we do the standardization on the side too, again, this will be now 62 minus 66 over 4 is -1. So this time, this is the area that you want. And again, you look to the table is going to give you all of this area. So this comes from the table. And the value on the table is 0.8413. Remember that X less than 64 is the same thing as the probability that Z is less than -1, which is the area here to the left. So we use the table. This will be 1 minus 0.8413, which is equals to 0.1587, or if you use the calculator, this will be normal CDF. The lower bound is minus 1,000, and the upper bound is -1. It will give you exactly the same answer. Remember that to access this, you need to do a second variables, and then number 2 will give you normal CDF. Question number 5, which is probably the hardest question that you'll have on the test, says this. In order to get into the Air Academy, you need to score in the top 2% of the placement test. So, what does that mean in an equation? That means this. Assuming the x, let's say, is the score in the test, so this is telling you that the probability that x is greater than some value of the random variable is equals to 0.02. Okay, so we had to work backwards in here. So this is the formula you need to use. And what you're really trying to find out is what's the value for x. Now, the question gives you the following information. It tells you that it's normal, which is very important. It tells you that mu is 600 and the standard deviation is 50. So the question is telling you pretty much how much is this, how much is this. This is what you're trying to find. Without knowing this, you will never figure out what x is. These two are given, so you have to figure out the value for z. In order to do that, you're going to need this. Remember that when you change from x to z, the probability doesn't change. The value changes, but the probability doesn't change. So therefore, what that means, remember, is that this is telling you that there is some z value, which we used to call a before, where this is equals to 0.02. So we use the inverse of this, which means you look to the table backwards. This is telling you, okay, there is some value for z, where this area is 0.02. So that means the area to the left has to be 0.98. Then you look to the table for either 0.98, or you can use the inverse norm from the calculator. You need to input the area to the left, which is 0.98, and this is around 2.05. Once you figure out this value, then it's very easy to solve the problem, because all you have to do is plug this into here. Since you already know these two, this is just a basic equation, and this is what we get. So you have 2.05 equals to x minus 600 over 50. If you cross multiply, you end up at x minus 600 is equals to 2.05 times 50, which is around 103. So this is 103, and if you solve for x, that means that x is equals to 703. So this is the minimum score you need in order to get into the Air Academy. Question number 6 is asking you to find a 99% confidence interval for sigma squared when n is 16 and s is 8. So here we have the alpha is 0.01. So the first step, you need to figure out how much is chi-squared, right? This is anything as chi-squared of 0.005, because alpha has to be divided by 2. The degrees of freedom is 15, because remember the degrees of freedom is n minus 1. If we look to the chi-square table, this is equals to 32.801. Step 2, you need to find out how much is chi-square left. This is chi-square of 0.995. Same numbers of degrees of freedom, and this happens to be 4.601. All we have to do after this is plug everything into the formula. Now we have all the information. So here, n, remember, is 16. So n minus 1 will be 15. S is 8, so u squared will get 64 divided by 2.801 less than sigma squared. This is the same number again, divided by 4.601. Now you simplify this and you run the answer to two decimal places, you end up with 29.27 less than sigma squared less than 208.65. And this is the interval for sigma squared. Then you still have to explain this, which just means that you are 99% confident that the variance is between these two values. Question number 7. Mr. Fit is interested in finding out the average number of days per day that Californians go to the gym. Here we have a sample of 64. X bar is 100 and the standard deviation is 30. So it's asking us to find 95%, so alpha is 0.05. So step 1, alpha divided by 2 is 0.025. 0.025, remember, is 1.96. Step 2, we find the margin of error, so this will be 1.96. Sigma is 30, n is 64. This is equals to 7.35, so we can round it to 7 because we're talking about days. Step 3 is x bar plus or minus e, which means 100 plus or minus 7. And then finally, mu is between 107 and 93. Remember that the last thing you have to do is explain what this means. And what this means is that you or whoever did this are 95% sure the Californians on average go to the gym, between 93 and 107 days per year. That's it. Right, part B is asking you how large of a sample is needed in order to have a margin of error of 4 days. So remember, margin of error means E, so E is equals to 4. The formula, C of alpha over times sigma, everything divided by E, and then you square the whole thing. So we plug the values in here, we will have n equals to 1.96 times 30 divided by 4. Then you square the whole thing, and this to 216, well, around 216. In question number A, it's asking you to find a confidence interval for the mean. You had to decide if you need to use Z or T. Since here n is equals to 16 and the standard deviation is not known, you only have the sample standard deviation, which is 500, then you had to use T since n is less than 30. We also have the x bar is 4,450. So now that you know you had to use T and not Z, you can start the problem. It's very important that you check that before you do the problem. Here alpha is 0.01. So step 1, alpha divided by 2, this is 0.005. Then we need T of 0.005 with 15 degrees of freedom. Remember that the degrees of freedom is equals to n minus 1. If we look to the table, this is equals to 2.947. Then step 2, the margin of error is 2.947, which is the value we just found, times the standard deviation divided by the square root of n. And this, if you round it to a whole number, is around 368. Then step 3, the mean plus or minus the sample error. This gives you 4,450 plus or minus 368. Remember, you had to use write the answer this way. This is 4,818 and 4,082. So this is the answer. And then the last thing you had to do is explain what this means, which means that you are 99% sure that teachers make between 4,082 and 4,818 per month. Remember that you can use a calculator if you want to skip step 1, step 2, and step 3. No matter what you do, you have to have a step 4 in this form, and you have to explain what this means based on the problem. You want to get all the credit for that problem. Finally, the true or false. The first one says the area to the left of chi-square left is the same thing as the area to the right of chi-square right. Well, that one is true for this simple reason. We have chi-square right here and chi-square left somewhere here. Remember, this starts in 0. So this area happens to be alpha over 2, but this area is also alpha over 2. So they are the same. So therefore, this one is true. Part B, for any random variable x, the variance is equals to np times n minus p. That's false because this is true for the binomial, but this is not binomial. It says any random variable, so therefore this is false. Part C says for any positive value, the probability that C. The first thing you have to do is draw a graph, and we'll show you if this is true or not. Let's say that A is here. Greater than A would be this part. Less than A is this part. But if you do less than A, which is this part, and then you subtract that from 1, you will end up with this part left only. So that's why this is true. Again, the probability that Z is greater than A is this part right here. Less than A is this. But remember, the whole thing equals to 1. So if you subtract this part, you're going to end up with this part left only, which is exactly just greater than A. Now, part D, every random variable has a probability distribution. And the reason why this is true is because that's the definition. You cannot have a random variable without a probability distribution. Part B, it says a binomial random variable, so it's specifying that it's binomial with p.4 and n equals to 20 has a mean of A. All you have to do is check. Remember, the mean is equals to n times p. Well, here the mean is 20 and p is 0.4, which gives you 8.0. So therefore, this is also true. For part F, all you have to do again is just a graph. You look at the normal table using symmetry. Greater than -1 will be this part. Less than 1 will be this part. You can see by symmetry it's exactly the same area, so therefore this one is also true. Part G, this one looks a little tricky, but you actually have done this many times before. You just don't know. Let's say that alpha is 0.05. So if you divide alpha by 2, you end up with 0.025. And in the other side, you'll have 0.05. Now, you already know what these values are. Sorry, this is 1.96. This is 1.64. So clearly this is greater. So therefore, this is also true. Part H says X is normally distributed even if the sample size is less than 30. That's not true, because if it doesn't say anywhere the distribution is normal, the central limit theorem requires that n has to be at least 30. So therefore, this is false. And finally, says for any normal, so you know it's normal, the probability that x is greater than some value for k is equals to this. This is true because that's how you find the standard values. This is just a different way of writing that. So therefore, this is completely